This is Lab 5, magnetic braking with the Faraday's Law, presented by myself. Here we go. So the goals of the experiment, overarching, were to collect and analyze data of the falling magnet. This will be collected as the magnetic will be falling through the aluminum foil. You'll see later in the procedure area that kind of what we're doing is put it into aluminum foil wrap, or like a roll, and dropping the magnet um, through that roll, and there's the weight and everything's in the later part. And then glow script will be used for analysis of the data. Preliminary result. Um, so the average T, or T stands for time, of the falling magnet was around 0.812 seconds, measured from the time that the magnet was dropped to the magnet hit the bottom of the counter, which the aluminum roll is on. The predicted time for the model was 0.440 seconds, which shows a pretty significant margin of error on that computerized model. The realistic one was nearly double. So the concepts used here, we're taking into account Faraday's law, obviously. As mentioned, the title of the lab is Calculating with Faraday's law. Magnetic force will be used. This will be the wire method, or the wire formula, measuring the magnetic force with the use of that magnet. Newton's third law will be used because we're dropping the magnet. Mass times acceleration, which the acceleration would be due to gravity, and the Ohm's law for resistance. So the variables present here, the system is the falling magnet, obviously, because that's what we're controlling there. The surroundings is the aluminum foil wrap roll, because that's the medium in which the magnet will be dropped, and the gravitational, I don't know why there's an S in there, but the gravitational force, because we're obviously dropping the magnet, and the acceleration and force of gravity is acting upon it. So F1 would be the magnetic force in the loop, and the F2 is the force on the magnet due to the Newton's third law or due to gravity. How? So magnet dropped through the aluminum foil tube. Total of 5 trials conducted. This is kind of procedure section. 5 total trials conducted. Time of the drop marked for each of them. Like I said, timer started when you dropped the magnet and then concluded when it hit the table. And then the glow script will be used to computationally analyze these results and compare a predicted model against the observed model. The predicted model will be the computerized model, and the observed model will be the experimental data collected from the actual drops. So results here, the time was 0.812 seconds. Length of the tube with the aluminum roll was 0.5 meters. Width was 0.005 meters. The inner radius was 0.002 meters. And the mass of the magnet was 0.018 kilos. Discussion here. Possible sources of error include the wind force that could be generated by nearby AC, because this was done indoors, and calculation errors. The drops is a split-second thing, and human error is possible. Error resistance is another variable of error, and measurement incorrectly due to human error. What if? I couldn't find the what if question for this lab on Canvas, but to further the experiment, one could use a more advanced magnet or complete the same experiment in a controlled environment in which human error and error resistance are not issues. Maybe something like in like a vacuum or something like that. But that is it for Lab 5. Thank you guys.